Hey Confluence Crusaders, I'm Chantel, the AmeriCorps Education and Monitoring Technician at Palouse Conservation District. And today, we're along Union Flat Creek where I'm going to be demonstrating Tier 2 data collection. The data you collect will help us so much in letting citizens learn more about the water quality, as well as help us implement more water conservation projects with the Palouse. Before we begin, here are all the materials you will need to conduct your Tier 2 observations. Make sure to double check the expiration date and all the reagents in this kit before going out into the field. If you find that anything is expired, you can fill out a restock request form on our website. You will need a dissolved oxygen kit, nitrate nitrogen tablet kit, precision pH test kit, a stopwatch, 1 liter sampling bottle, liquid disposal bottle, tap water bottle, plastic bag, and a coffee filter. Make sure that after you use any test tubes in these kits, rinse them out with tap water and allow them to dry. If you don't take all of these steps, it can lead to inaccurate results when you reuse the kit. This data should be collected monthly, and we recommend that you sample midday when there is lots of sunlight, because much of your sampling will be determining the colors. Make sure to write down all of the observations you make so that you can report your results later into the Survey 123 app. So now I'm going to be demonstrating on how to collect a water sample. You always want to make sure that the stream conditions are safe. If you have any question as to what's safe and not safe, you can refer back to our introduction video. When you're collecting your water sample, you want to make sure you're collecting upstream so you avoid picking up disturbed sediment. When measuring your water sample, you want to make sure that you read the meniscus. If you are unsure what the meniscus is, you can always refer back to the handbook. We are going to start off by testing the amount of dissolved oxygen using the dissolved oxygen kit. Dissolved oxygen is important for the aquatic life to survive. Oxygen is added to the water from the atmosphere through mixing in turbulent areas, like rapids in a river. Aquatic plants also contribute oxygen through photosynthesis. Both decomposition and respiration require oxygen, thus lowering the dissolved oxygen concentration in the stream. Since cold water holds more oxygen than warmer water, dissolved oxygen levels can fluctuate a lot, going down at night until photosynthesis resumes at dawn. They can also fluctuate through seasons. In the summer, there is less dissolved oxygen due to less turbulence with drier streams and warmer water. Runoff water tends to have low dissolved oxygen and typically transports chemicals or biological pollutants. These pollutants require oxygen to decompose and end up lowering the waterway's dissolved oxygen levels further. First, let's go through the supplies you have in your kit. A sample cup, self-filling ampules, color standards. Now, let's get a water sample from the stream. Now that I've collected my sample water, I filled up my sample cup to 25 milliliters. I'm going to put my ampule into the sample cup. You're going to apply some pressure, and it may feel like it's going to break in your hands, but it's not. That's the pressure needed in order to break the tip. And you're going to wait until the ampule fills up with water, and there's going to be a bubble, and you want to make sure you bring it back and forth so the bubble moves from the top to the bottom. And you want to do this a few times, and then you're going to wait 2 minutes to record the measurement of the color. So it's been about 2 minutes, and now I'm going to compare my sample to the standards. And you want to make sure you do this in the sunlight so the colors are accurate. And I can see that my sample is somewhere between 10 and 12. And if you find that your sample's in between, you want to make sure you find the average of both. And record your answer in milligrams/liters. Now it's time for cleanup. You're going to place your used ampule into a sandwich baggie. And you're going to pour out your sample water into the disposal bottle. We have a coffee filter here on the top to catch the glass broken off from the ampule. But note, sometimes it gets caught in the bottom and you may have to go home and take this out at a later time. You're going to rinse out the sample cup with tap water. And you want to make sure you do this twice to ensure that everything gets out. One down, 2 more to go. The next test we will be conducting is looking for nitrates in the water. So you will need the nitrate nitrogen test kit. Nitrate is a form of nitrogen that is easily transported by runoff and commonly is found in streams. Nitrate can come from soil organic matter, animal waste, decomposing plants, sewage, and fertilizer runoff. It is a form of nitrogen that we can measure in the water. Having too much nitrogen can promote algae blooms and excessive plant growth, leading to the water to have less oxygen. Measuring nitrate can also help us understand more about nutrient runoff from agriculture. First, let's go through the supplies in your kit. Nitrate number 1 tablets, nitrate number 2 tablets, 2 test tubes, 2 protective sleeves, a nitrate nitrogen slide bar, and an octa-slide tube viewer. I have filled up my sample tube to 5 milliliters of sample water, and I'm going to put nitrate tablet number 1. You want to ensure that it's number 1 and not number 2 that you're using. You're going to wait about 2 minutes until the tablet is completely dissolved. It's been about 2 minutes and the tablet has fully dissolved after I've shaken it. It's now time to add nitrate tablet number 2. You're going to put it into your sample tube, cap it, and wait another 2 minutes until the tablet has been fully dissolved. So it's been about 7 minutes now. Your tablet should have dissolved after 2, and you want to give your sample about 5 minutes in order to read the color correctly. I'm going to insert it into the slider, and you want to make sure you're in the sunlight so you can read your colors correctly. I can see that my sample is reading about 2.0, and if you have anything in between, you want to find the average. After you found this number, you want to multiply it by 4.4 and record your answer as milligram per liter nitrate. So now it's time for cleanup. You're going to dispose of your sample into the disposal bottle. And you want to clean out the tube twice with tap water to ensure that everything has gotten out. The last sample that we will be taking is to measure the pH balance of the stream. pH is a measure of how acidic or basic a liquid is, in this case, the stream. pH is measured on a scale of 0 to 14. A pH of 7 means that the water is neutral, like distilled water. Greater than 7 on the pH scale means that the liquid is basic or alkaline, like milk. Less than 7 on the pH scale means the liquid is more acidic, like lemon juice. The pH of the stream water is influenced by the concentration of acid in the rain and the types of soils and bedrock in the watershed. Typically, the rainfall in the U.S. is slightly acidic, with a pH ranging from 5 to 5.6. As rainwater falls, carbon dioxide from the atmosphere dissolves into it, thus forming a weak carbonic acid and lowering the pH of the precipitation. Acidic water can be harmful to the health of aquatic communities. Heavy metals in the water can also be toxic, with a lower pH due to increased solubility and bioavailability. Most aquatic life require a pH of 6.5 to a 9 to survive. To test the pH of the water, you will need the Lamont Precision pH Test Kit. Let's take a look at the supplies in your kit. pH indicator, 2 test tubes, 2 color slide bars, and a slide viewer. So next, I'm going to measure the pH of the stream. I filled my test tube with 10 milliliters of sample water, and now I'm going to be putting in 10 drops of the pH indicator. Now that I've shaken my sample, I'm going to insert it into the viewer so I can compare it with the standards. You're going to make sure you're in the sunlight so you can get an accurate reading. And I can see that my reading is 8.0. And if it's in between, you're going to want to find the average. Now it's time for cleanup. Before you dispose of anything, you want to make sure you take a picture of your results so you can put it into the Survey123 app. I am going to dump my sample water into the disposal container. And you're going to rinse out the tube twice with tap water. Thanks for following along. If you have any questions about Tier 2 data collection, be sure to review the Confluence Crew Handbook. The handbook contains more information that will help you interpret the conditions that you're seeing at your site. You can also reach out to PCD staff with any questions. We appreciate your help in our research of the waters along the Palouse.